for chapter 2, where you can watch over and over, or just listen to it while you're driving or something like that. Okay. So test on Wednesday, guys. Test 1 on Wednesday. Pat, you were asking.
And homework due on that day too.
Homework due on whenever you see a test day. That's what homework is due. So I already sent you guys chapter 1 homework, right? Everybody has that? Okay, I sent you guys that homework already. And we happen, like say for instance, on Friday, I'm pretty sure I can be done with chapter 2 by Friday. I can probably get those, at least half of chapter 2 done by Friday. We may have a little review on Monday so we can be able to go over the homework and answer those questions, okay? Okay. But how I usually do that, like, I'll take your homework and then we usually have time to discuss homework. That's how I try to save us a little time to discuss homework. Okay. So this is our clinical schedule right here, guys. See, we don't have a lot of like holidays or off days, but if you're by the 13th, if you don't have anything, that'll be a long vacation for you. Long vacation for you.
January 7th. Until January 7th?
Yeah, until then. Nice long holiday. Yeah, and it's the only like day off we have right here, International Day. That's the funnest day of the semester, guys. Real great day. We're gonna talk about it more as it's approaching. Any questions on the schedule, guys? I think I tried because I thought about last year, and I tried the chapters I needed more time in. Like, let me see. Look at like chapter 6. I have 4 lecture days on chapter 6 because it's kind of a long chapter. It's really like 2 chapters in one. So I wanted to make sure we have enough time. So with this schedule, I feel like I have enough time to teach you guys everything we need to learn. Okay, we're golden. Sweet. All right, guys. I don't have a PowerPoint for chapter 1. Because I didn't feel like it was needed. I feel like hopefully you guys can read it. And, that was good. But I do have I have my own notes. We kind of go through that right now. So, guys, let's start chapter 1, page 2. Sorry, page 1. Guys, if this is not a review for you guys, by show of hands. I mean, it's not like it doesn't matter if you read today or not. But by show of hands, have anybody read the chapter? Anybody read the chapter? By show of hands. Okay. That's good stuff about people that have read. Hopefully, this is a review for you guys from stuff you already know. Everybody has at least an associate's degree, so hopefully this chapter right here is very, very, very easy. I need to figure out a new word for easy. Give it a synonym. For that. Anybody got one? Not challenging, not as challenging. Where am I? Hey Siri. Get everybody phone on. Hey Siri, what's in the
simple, soft, flat, slick.
I don't like any of those.
Handy.
That was easy.
Light.
Those are synonyms.
Comfortable.
I don't like any of those.
Convenient. Relaxing.
Refreshing. Okay.
Refreshing. Okay. I like that. Guys, do you guys need this right here?
No.
Y'all have that already?
What else?
15. Y'all got your call-in number, right? I'm gonna kind of come out of the book a little bit, guys. But for the most part, I'm gonna be explaining. I'm not gonna go line by line out the book. Okay. So it seems very basic, but we all know graphs are using ultrasound. Remember we talked about spectral analysis last. Anybody remember what a spectral analysis is?
Yes.
What is it, Uber, since you said yes? Interesting. Somebody help Rob. Anybody remember what a spectral analysis is? I know you're rusty. What's a spectral analysis? There we go, Pat. There we go. So you guys know we use graphs. So when we look the spectral analysis, that's when we're using our pulse wave Doppler, right? When it's showing, so we have our graph and we have our waveforms like that. Remember that's pulse wave Doppler right there. That's our spectral analysis. Remember, that was a synonymous term. Post-wave Doppler, spectral analysis, those are synonymous terms, okay? So the reason graphs are important when it comes to ultrasound is because we're always like, when it comes to Doppler, we're always gonna have to measure velocities and things of that nature, okay? So that's why knowing graphs are important, okay? So really important when it comes to hemodynamics and blood. We'll talk about that, in the future or as the semester goes on, okay? But we all know, hopefully we all know, there are two axes on the graph, right? The x-axis being the horizontal axis, right? Do I have to write it up here for you guys? Or we know these things? When? We good? So I gotta write it for you, we know these things. Okay, it's in the book anyway, right? It's in the book anyway, got it. So the x-axis, of course, is the horizontal axis, it runs side to side, okay? And our y-axis is our vertical axis, it runs straight up and down. So when you have a graph, you're basically, with us having these two axes, we're comparing two different points, right? It's having a relationship, all right? So also, don't forget, you also have a z-axis, which is like, we'll talk about that more when we're talking about M mode and how that works. So, pen. Where's that other eraser?
Down there.
Oh. Man, I just bought this eraser myself last semester. So, X, Y, and then you also have the Z-axis right here. We'll talk about that, like I said, when it comes to talking about M mode. Get more in depth about M mode. So these are our axes, guys. I'm not gonna go into in depth that. I'm trying to be as plain as it can be. X-axis horizontal, vertical axis would be the Y-axis, which is straight up and down. Okay. Most of the time, at this point, even when you have you can continue your graph like this, like you have like in college algebra or pre-calculus. All of this is still X. This is still Y. Normally, this point right here would be 0 right here. Okay. But we're pretty much going to focus on this aspect of right here. So this is our 0 point, and normally it's counting up. So 0 to, I'll say 15 right there. But this doesn't rise over run. It doesn't necessarily have to start at 0, right, guys? If my points if it starts at 15, then that's just the starting point. Okay, it's a starting point, but it usually increases as it travels. Okay. So that's all I have about axis right there. God, I do have little notes right here. I usually hand these out, but then I know that the students don't pay attention when I give you this. When I send you this ahead of time, because I always make my own notes. So I usually send you guys this. I may send it after the fact, though. After the fact, but I take my own notes. So that's all I have. Any questions on graphs, guys? I don't want to say we should all know this, but hopefully we all know this right here. I don't want to be beating a dead horse. I've said it like 5 times already, but hopefully we're good on that. There you go. All right, guys. Next page. And usually I'm going to come, but this chapter right here, I'm going to come straight down the way the book is set up. Okay. So let's talk about definitions, guys, and relationships. When we talk about ultrasound, everything we do is based on a relationship of how one thing affects something else. So, for example, if I have a transducer that's really high frequency, I know that's going to affect the length of that pulse. Okay, so the higher the frequency, the shorter the length of the pulse. And knowing those relationships is really important with ultrasound. For my people that have read chapter 3, talking about acoustic parameters, we're going to have to know that's when it comes to the SPI, it's all about relationships. How does the PRP affect the PRF? How does the period affect the frequency? How does the wavelength is affected by the spatial pulse length? Things of that nature, okay? So it's all about relationships, and we're kind of going to start with these basic relationships and talking about them, okay? So again, real quick, the first one will be unrelated. Don't have to talk about that. We know these are items that have nothing in common. They don't have a relationship at all. Like the book has something that's unrelated, like your hair color, your shoe size. You know what I mean? Those two things are unrelated, right? One thing won't affect another. The size of my shoe is not gonna affect my hair color, okay? So, that's unrelated. So for example, let me give you something that's unrelated in ultrasound. The period of an ultrasound pulse is not related to the pulse repetition period of ultrasound pulse. They're unrelated, okay? So knowing their relationship, because sometimes the SPI likes to give you trick questions as far as like, what's the relationship between PRP and period? And you're gonna sit there thinking about it, but those two things have nothing to do with one another, okay? Because period is just talking about a cycle, a single cycle, and PRP is talking about a pulse. A pulse meaning 3 or more cycles that will create a pulse. Okay. So when I talk about one cycle, this is one cycle right here. That's one cycle right there. So this will be the period. I can calculate the period with this right here. But if I'm talking about the pulse repetition period, I would need 3 or more cycles for it to be talking about pulse repetition period, okay? So when I talk about period, that's only related to a cycle or cycles. When I talk about pulse repetition period, that's related to a pulse. Pulse being 3 or more cycles, okay? We're good there, guys? And? Okay, we're looking like. All right, so let's talk about things that are related, guys, and we talk about in this chapter, related and proportional mean the same thing. Okay? Related and proportional mean the same thing. Okay? So things that are related are 2 items that are associated or affiliated in a relationship that does not have to be specified. So an example I like would be 2 things that are related, not necessarily one affects the other as far as value goes, would be, I would say, I don't know, let's say Thanksgiving and turkey. You know, we know that those 2 things are related, you know, but their relationship between those does not have to be specified, right? Because that one thing doesn't affect another. It's not going to change the value of something else. Christmas and Santa Claus, you know, those are 2 things that are just related. That's it. Weight is related to diet. There's an example that the book gives you. Okay, they just have a relationship. They don't affect each other. Okay, as far as value goes. Okay. So related or proportional, all right? So next thing we have page 2 would be things that are directly related or directly proportional. Those terms are synonymous, all right? So these are 2 items that are associated, and when one increases, the other increases, or vice versa. You know, they affect each other the same way. One increases, the other increases, or one decreases, the other decreases. Anybody can give me an example that's not in the book of 2 things that are directly related? Anybody?
The more helium in a balloon, the bigger the balloon.
The more helium you add,
The more air you blow in.
I think that's just a relationship. Is this a relationship? I see where you're coming from. I see where you're coming from.
temperature,
Temperature and what?
temperature, like when it's the temperature, it's
The more money you have, the more stuff you can buy.
I like that, dude. That's
what?
true. The more money you have, the more stuff you can buy.
But there is not a specific relationship.
Huh?
There is a specific relationship in this, or
Yeah,
just
because if I don't
related?
have money, then I can't buy it. That value affects one other thing.
Oh,
If I have a lot of money, I can buy what I want to buy. If I don't have a lot of money, I'm eating ramen noodles.
Yeah, there is a relationship, but I thought you want like a model, a specific.
I like the best example I like in this book would be pertaining. That would be skill and practice. I really like that example. My skills are gonna be really high if the more I practice. Okay, I really like that's a direct relationship. When we think about those on the graph, that's you see how my z-axis is. If that was my say for instance my x-axis was weight. I'm sorry, was skill. Man, I got too much going on here. If my x-axis was skill, this is skill, and my y was what was the other one? Skill and practice, right? Practice. If we had to graph this would look like this would that line right there would make a direct relationship between those two because as you can see, this is 0 again. That's 15. that's your team, the more skill I have, that means probably mean I put in a lot more practice than somebody else.